According to the National Electrical Code, specifically Article 210.19, A4, branch circuits supplied from a three-phase, four-wire, Y-connected system are required to have a neutral conductor. The situation involves a 175-watt metal halide fixture mounted on a 15-foot pole, which is fed by a 480-volt circuit. The assessment is that this setup constitutes a violation of the National Electrical Code. The critical point of contention lies in the absence of a neutral conductor in the circuit that feeds the fixture. The National Electrical Code mandates that branch circuits derived from a three-phase, four-wire, Y-connected system must include a neutral conductor. In the described scenario, the fixture is powered by a 480/277 volts three-phase, four-wire circuit. The issue is that the circuit lacks a neutral conductor at the fixture location. Consequently, the fixture's grounding is deemed inadequate, leading to a violation of the National Electrical Code. The rationale provided by the engineer and local inspector suggesting that the grounding conductor suffices as a substitute for the neutral conductor is incorrect. The National Electrical Code explicitly states that a grounding conductor cannot fulfill the role of a neutral conductor. This discrepancy introduces a safety hazard. Without a proper neutral connection, the fixture could potentially become energized, posing a risk of electrical shock. Therefore, it is imperative to rectify this violation immediately to ensure compliance with safety standards and regulations. The absence of a neutral conductor in a 480-volt circuit feeding a metal halide fixture represents a significant safety concern as it deviates from the requirements outlined in the National Electrical Code. To reiterate, National Electrical Code Article 210.19 A4 stipulates that branch circuits sourced from a three-phase, four-wire, Y-connected system must incorporate a neutral conductor. The key takeaway is that the grounding conductor cannot serve as a replacement for the neutral conductor. The reason for this requirement is to ensure proper grounding and prevent electrical shock hazards. The neutral conductor provides a low impedance path for fault current to return to the source, which helps to trip the circuit breaker or fuse and to energize the circuit in the event of a fault. Without a neutral conductor, the fault current may not have a clear path back to the source, which can result in a build-up of voltage on the fixture and increase the risk of electrical shock. Moreover, the absence of a neutral conductor can also lead to equipment damage. In the event of a fault, the excessive current can flow through the equipment grounding conductor, which may not be able to handle the current and can overheat, potentially causing damage to the equipment or even a fire. Therefore, it is essential to ensure that all electrical circuits are properly grounded and have a neutral conductor when required by the National Electrical Code. It is also important to consult with a qualified electrician to ensure that all electrical work is performed in accordance with the National Electrical Code and local regulations. In summary, the scenario involving the 175-watt metal halide fixture on a 15-foot pole fed by a 480-volt circuit without a neutral conductor is indeed a violation of the National Electrical Code. This is because the grounding conductor cannot be used as a substitute for the neutral conductor. This violation poses a safety hazard and needs to be corrected immediately. The primary concern with the described installation is the potential for electrical shock due to improper grounding. The neutral conductor in a properly wired circuit provides a safe path for fault current to return to the source, allowing the circuit breaker to trip and to energize the circuit in the event of a fault. Without a neutral, the fixture's metal parts could become energized, posing a shock hazard to anyone who comes into contact with it. It is crucial to understand the difference between a neutral conductor and a grounding conductor. The neutral conductor carries the unbalanced current from the load back to the source under normal operating conditions. The grounding conductor, on the other hand, is intended to provide a path for fault current to flow back to the source in the event of a fault, such as a short circuit or ground fault. The grounding conductor is not intended to carry current under normal operating conditions. In a three-phase, four-wire, Y-connected system, the neutral conductor is connected to the center point of the Y, which is typically grounded. This provides a reference point for the voltage and helps to stabilize the system. The absence of a neutral conductor in a circuit can also lead to voltage imbalances and other problems. For example, if one phase of the circuit is heavily loaded and the other phases are lightly loaded, the voltage in the heavily loaded phase may drop, while the voltage in the lightly loaded phases may rise. This can cause problems with equipment that is sensitive to voltage variations. In addition to the safety concerns and potential equipment damage, violating the National Electrical Code can also have legal and financial consequences. If an electrical inspection reveals a code violation, the property owner may be required to correct the violation at their own expense. They may also be subject to fines or other penalties. In some cases, code violations can even lead to legal action. To avoid these potential problems, it is essential to ensure that all electrical work is performed in accordance with the National Electrical Code and local regulations. This includes ensuring that all circuits are properly grounded and have a neutral conductor when required. It is also important to consult with a qualified electrician to ensure that all electrical work is performed safely and correctly. The engineer's argument that the 480/277 volts 3-phase, 4-wire system somehow negates the need for a neutral at the fixture is incorrect. While it's true that this type of system can provide both 480 volts and 277 volts, it doesn't eliminate the requirement for a neutral conductor for 277 volts loads. The 277 volts is derived from the phase to neutral voltage in the 480/277 volt system. Therefore, if the fixture is designed to operate on 277 volts, it needs a neutral conductor to complete the circuit. The fact that the circuit feeding the panel is a 480/277 volts 3-phase, 4-wire system is actually further evidence that a neutral should be present. This type of system is specifically designed to provide both 480 volts for 3-phase loads and 277 volts for single-phase loads, with the neutral conductor serving as the return path for the 277 volts loads. The inspector's approval of this installation is also concerning. Electrical inspectors are responsible for ensuring that electrical work is performed in accordance with the National Electrical Code and local regulations. If an inspector approves an installation that is clearly a code violation, it can put people's safety at risk. It's important to remember that the National Electrical Code is not just a set of guidelines. It's a legally enforceable standard that is designed to protect people and property from electrical hazards. Electrical safety is not something to be taken lightly. It's essential to follow the National Electrical Code and other relevant safety standards to ensure that all electrical work is performed safely and correctly. If you are not sure whether an electrical installation is safe or in compliance with the National Electrical Code, it's always best to consult with a qualified electrician. Ignoring electrical safety can have serious consequences, including electrical shock, fire, and even death. Therefore, it's always better to err on the side of caution and seek professional help when necessary. In conclusion, the 480 volts metal halide fixture without a neutral conductor is a clear violation of the National Electrical Code and poses a significant safety hazard. The engineer and local inspector are incorrect in their assessment of this situation, and it's crucial to correct this violation immediately to ensure the safety of people and property. The absence of a neutral conductor can lead to electrical shock, equipment damage, and legal consequences. Therefore, it's essential to follow the National Electrical Code and other relevant safety standards to ensure that all electrical work is performed safely and correctly. Remember that electrical safety is everyone's responsibility, and it's always better to err on the side of caution when dealing with electricity. Here are some additional points to consider. Firstly, the specific requirements for grounding and neutral conductors can vary depending on the type of equipment and the voltage of the circuit. It's essential to consult the National Electrical Code and other relevant standards to determine the specific requirements for each installation. Secondly, even if the equipment is designed to operate without a neutral conductor, it may still be necessary to provide a grounding conductor for safety. The grounding conductor provides a path for fault current to flow back to the source in the event of a fault, which helps to trip the circuit breaker or fuse and energize the circuit. Thirdly, it's important to ensure that all grounding and neutral conductors are properly sized and installed. Undersized or improperly installed conductors can create a safety hazard and may not provide adequate protection in the event of a fault. Fourthly, regular electrical inspections are essential to identify and correct any potential code violations or safety hazards. Electrical inspections should be performed by a qualified electrician who is familiar with the National Electrical Code and local regulations. Fifthly, education and training are crucial for ensuring electrical safety. Electricians and other electrical workers should receive regular training on the National Electrical Code and other relevant safety standards. Property owners should also be educated about electrical safety and the importance of following the National Electrical Code. In addition, it is crucial to verify the integrity of the grounding system. The grounding electrode conductor, which connects the grounding system to the earth, should be properly sized and connected to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode should be installed in accordance with the National Electrical Code and local regulations. It is also important to ensure that all metal parts of the electrical system are bonded together to create a low impedance path for fault current to flow back to the source. This bonding helps to prevent voltage differences between metal parts, which can reduce the risk of electrical shock. Bonding can be achieved by connecting metal parts together with bonding jumpers or by using metal conduit as a bonding conductor. Furthermore, it is important to consider the environment in which the electrical equipment is installed. If the equipment is installed in a wet or damp location, it is important to use equipment that is specifically designed for use in such environments. This equipment is typically designed to be waterproof or water resistant and to prevent the ingress of moisture, which can lead to corrosion and electrical shock hazards. In addition, it is important to protect the electrical equipment from physical damage. This can be achieved by installing the equipment in a location where it is not likely to be struck by vehicles or other objects. It is also important to protect the equipment from vandalism and theft. This can be achieved by installing the equipment in a secure location or by using tamper-resistant hardware. In summary, the installation of a 480 volts metal halide fixture without a neutral conductor is a serious violation of the National Electrical Code that can have significant safety consequences. It is important to correct this violation immediately and to ensure that all electrical work is performed in accordance with the National Electrical Code and other relevant safety standards. This includes ensuring that all circuits are properly grounded and have a neutral conductor when required, that all grounding and neutral conductors are properly sized and installed, and that regular electrical inspections are performed to identify and correct any potential code violations or safety hazards. By following these guidelines, you can help to ensure the safety of people and property and to prevent electrical accidents.